Sine over cosine is wrong. It should be whatever it is. It depends on how the problem is set up. Plug that into a calculator and find out the angle is. So it's going to be tangent inverse.
Yeah, I had randomly lots of people home yesterday, and then kind of extended it one more day. You're able to finish them, okay?
Yeah, it's just cool. So the angle is.
Alright, kiddos, let's go ahead and focus back on it. I want to see how many of the pieces you were able to put together. I want to see how many of the pieces you were able to put together. So go ahead and as you go ahead and turn to the balloon problem. Everybody looking at the balloon problem. I lost the focus of a lot of the groups quite a while ago, so let's go ahead and focus on it. Because when things stop being productive, we need to go and switch gears. So, balloon problem. Okay? How were you guys who found each other yesterday able to connect the pieces as to why each of the clues went together? Help me out. Who had the balloon problem yesterday? How did you find each other? What are the things you did? How did you put the pieces together? Okay, according to the problem, you know you needed volume, so there needed to be V's and stuff, and then pretty much in all the clues, what is there? There's a V in that one, there's a V in that one, there's a V in that one. Yeah, and radii too. You had the sphere, it was the only problem that had a sphere. And then how'd you know feet per minute?
Because it's given it as.
It's not given. Feet per minute is not.
How
How fast the diameter per time, and what's the diameter going to be measured in? Feet. Good. So feet per minute. Good. How do we connect the pieces? Some of you guys have been working on this one. Some of you guys just kind of have been silent observers. Question. How do I take related quantities? How do I take these geometry formulas, and how do I get to rates to hopefully get down to this one? What do you guys do? Take the derivative. Take what derivative? Not ddt of both sides. Good. When you take ddt of volume, what do you get? dvdt. And when you take ddt of the other side, how do you take the derivative of this? Power rule. Wait. Why not product rule? That's a constant. So technically, constant multiple rule says second d first, it's just going to be 0 anyway. So you can leave the 4/3 pi. Oh wait, hold on, but power rule of r, right? That's going to be 3r squared, and what else hopefully did you put? dr dt. The r and the t doesn't match either. The 3's go ahead and reduce. Well, that's not what's here. Why is this different?
The derivative.
Because you need to figure out, you need to find d dt. So dr dt is not enough. He's not what I want. So how did you guys use this clue? Or did you? Take the multiply by 2. Oh, don't do that. You have the idea. You need to use the relationship, but I don't know anything about rates yet. I have to. Brandon, say it louder.
Find the derivative.
Find the derivative. So I can say d dt is equal to what? What's the derivative of this side? 2 dr dt. So then can't I divide by 2 multiplied by 1/2, and then can't I plug it in? Right? So I can get rid of dr dt and plug in 1/2 d dt. And then I go ahead and have 1/2 times 4, that's 2, and there's the pi, and there's an r, and there's a square, and there's d dt. Sweet. What happens once you have this formula? Plug in what you know, and what do you know? Everything. Because you have 2 pi, you know that r is 1 at this instant, and you know d dt is, well, you don't know him. Hold on, who do you know? Exactly, so I can plug in. Did you guys think about the scenario? The balloon is getting bigger, right? So then we plug in the positive 3, and then we solve. You could go ahead and have decimals, or you could have fractions, because it ends up to be 3/2 pi per minute. Or if you did get a decimal, did anybody do that? 3 decimal places? What's 3 over 2 pi, Corey? 4 point, remember, always 3 decimal places. Always, so 4 point what? Nice. 4.7. 0.477. How many groups beat me to 0.477 or 3 over 2 pi? Okay, 3 groups. 4 groups. Okay. Next problem. I want you guys to go ahead and focus in on the ladder problem. Good stuff. Ladder problem. Switch it up. Ladder problem. The ladder's slipping, right? Did anybody think about the motion or the movement? The height of the ladder on the wall is changing. The distance on the ground that it's hitting is changing, but what's not changing? What's non-changing? The size of the ladder. And the size of the ladder would be what side? X, Y. Why is there a Z here but not here? Z is 13. It's constant. As the ladder falls, the 13 doesn't change. So I could change this equation to be x squared plus y squared equals 169, or 13 squared, before I take the derivative. Then when you take the derivative, then you end up with, well guys, don't you just go there? Now what if you didn't realize that? What if you took the derivative, and then you were like, oh stink, so I have clues for the x's, I have clues for the y's, but I have no idea what's going on with dz dt. I haven't even written him. He's not even there. What would you have to think about?
0. The rate 0.
Exactly. If it's not changing, the rate is just 0, and that would fix it too. If it's not changing, the rate is 0, so that means, oh, okay, I can get here another way as well. But if you can figure out what's constant or what's non-changing at the beginning, then it's going to make it a little bit easier for you to get to the formula you need. Now, there was one other struggle, though. When you went to go plug in, you're like, sweet, 2 times, who's x?
You gotta use the diagram.
I'm not supposed to know dx dt. I do know y, because they gave it to me as a such that. I do know dy dt, negative 2. It's negative because it's decreasing. Some of you might have missed the negative. But the distance up the wall is falling, so the rate is a negative. The amount is decreasing, or the height is decreasing. And then equals 0, but some of you got stuck right here, except, hold on. If I know that x squared plus, at my instant, y is 5, and I know that z is 13, can't I find x? And after some quick manipulation, or I just should just say algebraic solving, you get that x squared equals 144, so x equals 12. And then when you guys solve, you should have ended up with 20 divided by 24, which would be one answer, but if you were trying to do the nifty-difty decimal-y thing, it'd be 0.833. If you guys notice, these are saved on the notes online and in the videos from today. Okay, ladder problem, check. How many groups beat me to 0.833? Only 2 that time. No, 3.
Oh wait, we did it.
Our next one. Baseball problem. Hey guys, are these situations different? They're different, but do they follow a system?
Yeah.
Okay. Okay. Alright, focus on it. The baseball diamond one. I think this one, the given and the find, is kind of one of the hardest ones to realize. I think this one, the given and the find, is one of the hardest ones to realize. Question, why is 30, if 30 is the rate at which this dude is running, why am I labeling dA dt as 30 and with a negative sign?
It's shrinking at the same time.
Because as the guy runs, yeah, this one is getting longer at a rate of 30, but this one's getting shorter at a rate of 30. His distance to third. Brandon, focus. Okay. So as the guy runs from second to third, we could just label this, but that makes a really ugly non-right triangle, and that's going to be law of cosines or law of sines. That doesn't sound fun. I'd much rather do Pythagorean, so I'm going to talk about this side instead, which is his distance to third shrinking. Shrinking, decreasing, hence why I made it a negative. We want to find how fast or the rate of change of his distance to home as he runs from second to third at the instant when A equals 20. Question: what happened to B? It doesn't change. Well, who is B? This distance doesn't change as a little dude runs from second to third. This is still staying 90. 90 is 90 is 90 is non-changing for that situation, for this scenario. So what could we do with our numbers? A squared, or our formula, plus 90 squared equals C squared. And what happens when you take a derivative? What's the derivative of 90 squared? He's gone, just like we need him to be. Do you see how plugging in the non-changing amount kind of makes your life a little easier? Otherwise, you would have left B squared and you would have gotten 2B dB dt, and then you would have had to say, well, I don't know dB dt. They didn't give me enough info. Oh, wait, it's not changing. It's 0. You can always make that jump if you need to. But if you can figure out who's not changing, if you think about the motion and the movement, say, oh, hey, this just stays the same the whole time as he goes from second to third. So now plug and chug. You guys help me out. What'd you plug and chug? Good. A is 20. dA dt is? Equals 2 times. How'd you get that, though? Hold on. I'm just writing dc dt. How do you solve for C, though? Exactly. You go back and you say, well, I better use that him because he tells me how A and B and C are all related. So I know A squared, well, they gave it to me. It's 20 squared. Plus B squared, oh yeah, that's 90 squared, equals C squared. And so you would have square rooted 400 plus what, 8100? Or 810. Is 810 a better way? And what'd you guys get? 92 point? Now, hold on. The dilemma is, did you guys read this? Only round the, oh, stinks. If you're only supposed to round the final answer, do you guys see a struggle if you try to just keep that rounded answer for your square root? So if you do 92.195, you're like, yay, I did 3 decimal places, but you rounded it. So now you're going to have error in your final answer. So different ways of doing it. You could just go ahead and write in here the square root of 8,500. And that way you don't have to round anything. That way you don't have to round anything. Or you could just in your calculator, scroll up and get the whole huge number instead of writing down just the rounded one. We don't want to round until the final answer. And so then we end up with, it's a negative number, right? Yeah. 2 times 20 times 30, all divided by 2. Remember, if you're dividing by multiple things, put them in parentheses so you don't mess anything up. And you get 6.5 with a negative. 6.5, but remember 3 decimals, so I think 0.8, yeah? And if you had rounded him, he would be a little off, and that's what we don't want. That's what the AP guys don't want, okay? So don't round too early, round at the end. How many groups got there before me? Alright, so about 3 or 4.
If you did round on the AP exam, but you still got the answer right, would they round?
They would give you all the points except for probably the final one, because on the AP for like a final answer with decimals, they literally tell the graders this exact decimal or this exact decimal. So if you round it early and your decimal is a little off, now sometimes it happens to work out, but that's dangerous. Just be careful. All right, last one, yeah. Rocket problem, and I kind of think that's weird. In a way, the weirdest. By people that made the rocket problem match, how helpful was the picture to making it match? Didn't all of you depend on the pictures, right? Question though, if you're doing a problem on your own, what do you have to do? You have to read it and figure out what's going on. You have to draw a picture and figure out the quantities, like label them, and then use those labels to give a given and find. It was still tricky even after having all these clues, but a lot of you guys, if you had the picture, you're like, okay, theta and y, it's kind of important. Let me talk about the y and theta. Oh, hey, I see, like, it's dealing with y's and thetas. Oh, hey, y's and thetas. Oh, hey. You need to be able to make those connections yourself, and that's what homework is practicing, hopefully. But I went ahead and labeled the height y, I labeled the angle theta, because as I read the scenario, the rocket was rising and the angle was changing, and they asked about those things. Like they told me the rocket was rising at a rate of, and then they said the angle, find the rate of change of the angle. If you can label the words, you're going to have a direction to go. If you can't label the words, you're just going to be like, these are dumb. You can still say they're dumb, but I want you to be able to do them, or at least get going on the system, okay? Why on earth did I use tangent of theta, and did anybody find my typo? What's my typo? In this problem, there's a mistake.
Oh, y over x.
Should ask me. Shoot. Yeah. Right? That messes everything up, kind of, depending on how you guys solve. But some of you might have been able to make the connection because you didn't realize the typo was the Does it make more sense? Who's x if that's y? Okay. But where did x go in this one? Why is it constant? As the rocket rises, what does not change? How far away the camera is from the launching pad. So what can I plug and chug? Before arriving, the non-changing quantity. So who's x? How far away is it? 3,000. So I can say tangent of theta equals y over 3,000. And my people that don't like this and say, ew, it's a quotient rule, I say, don't worry, just rewrite it. What's another way of looking at it? 1 over 3,000 times y. Is that a nice rewrite? Because then when we go to take a derivative, we say sweet derivative of tangent of theta is secant squared theta d theta dt, and derivative of 1 over 3,000 y is 1 over 3,000 dy dt. Would the quotient rule have worked? Yeah. Bottom d top would be 3,000 times 1 minus top d bottom, which is b 0, all over bottom squared. It ended up just being 1 over 3,000 dy dt. Katrina, go ahead.
I'll actually wait because they didn't do it.
Okay. But so far, did I connect the pieces to how to take the derivative to get there? Derivative of tangent theta, secant squared theta d theta. Derivative of 1 over 3,000 y is 1 over 3,000. Now I need to plug and chug, right? Okay, so when I plug and chug, what do I get? Secant squared theta, but the problem is, who's theta, right? So I'll start from this side. This side looks nicer. 1 over 3,000 times 880. What's on that side? Who's theta? What did we do in all the other problems when we didn't know quantity? We went back here and said, can I find it? So I am going to do secant squared of somebody. I'm going to get back to that somebody. D theta dt is who I'm trying to solve, so he's allowed to stay. What haven't I used yet? The random y equals 4,000. But don't I have a formula that says, hey, you can find theta if you just could know y and who's x again? All right, cool kids. Calculus, radians or degrees? Always. So then how do you solve tangent of theta equals 4,000 over 3,000? Arctangent or tangent inverse in radian mode of 4,000 over 3,000. And I'm going to technically, just to make things... Would you guys get as a decimal to give me as many decimal places as you can?
92729.
I'm going to do dot, 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 because we're going to take that entire number, we're going to store them, or we're going to go access them when we get down to secant squared. Some of you are having the debate. I heard you talking it out. How do you do secant squared? Well, ew, gross. Who is secant squared?
Over cosine.
1 over cosine of your 0.92729 dot, dot, dot. Remember, squared is you do the entire cosine and you square it. That's d theta dt equals 880 over 3,000. How do I solve for d theta dt?
Multiply both sides.
Multiply. Good. Multiply it up. And And we should end up with, if we do it correctly, 80 divided by 3,000 times parenthesis cosine of, I'm just going to go ahead and do tangent inverse of 4 over 3. So I don't have any rounding error, but you guys might have already done that. Close all those parentheses, square that little baby cosine, and say 0.1056, meaning 0.106.
Can you try showing the given, like what's the whole
Oh, from up there? Is that what you wanted? What's that? Okay, go ahead.
It's off by the placer one.
There you go. Alright. We are done with our related weights examples for right now. Okay, let's talk about logistics. We haven't gotten to do that today. My day got thrown off just a little bit, but it is what it is, and God is still good, so even though our plans get thrown off, we'll be okay, right?
Yeah.
Right, left. Coming back. When was our test supposed to be? Why on earth does it say Friday when I already had to move it from Wednesday because of the PSAT? And it was technically supposed to be today, but I was trying to be gracious and give you a little more time. What's on Thursday during periods 1 and 2?
Oh, seriously?
Big one's coming. Thank you, California.
Okay, wait. We have some more stuff to do today, but there's the Great California Shakeout during periods 1 and 2 on Thursday. Yay. So your test is on Friday. I don't want to hear any complaining. I went and looked at the test calendar. Friday is packed, but what do you really expect teachers to do? Right? Especially teachers with seniors and juniors all in the same class. Juniors, if you're like, I don't get Wednesday or Thursday, you get an extra night. Just stop. I'm doing the best I can. If you randomly have 6 period free in your TA, you can come in and have class there. I'm going to be taping Wednesday, Thursday, if we do anything besides work days, etc. So that way you guys need to watch the videos, etc., because we'll be doing more, obviously, in period 6 on Wednesday and Thursday than we are in here, but we're just reviewing, okay? We're just reviewing. So in a way, homework was supposed to be due today. Why didn't we grade it? I wanted to finish these examples so that you see 4 fully worked out related weights problems. And in a way, seniors kind of have a work day tomorrow to work on their homework / their test review on the homework page. So then underclassmen, you might need to think about how to prioritize your time to work on the test review in section 2.7. In a way, listen, stop. We still have like 8 minutes. Why are you backing up or wrestling? In a way, homework is due on Thursday. But listen carefully. On Thursday, do you want to be barely finishing 2.7, still have tons of questions, and then have to be like, oh crud, there's a test tomorrow? No. Okay? So, there are test review problems at the end of this section. I'll probably, just because we do have extra time, I'll compile some multiple choice questions, kind of like test questions, maybe like a practice test, but a little one that I might work on somewhere, maybe Thursday or Wednesday. I'll post online with answers, etc. But I'm trying to give you ample things in order to prepare. This test is going to be on implicit. It's going to be implicit differentiation. It's going to be on inverse derivatives and inverse trig derivatives. And then it's going to be on related rates. But kiddos, don't you also have to know your derivatives of b to the u and log base b of u? And all of those can come back. All of those can come back and be in these problems. So you have to be reviewing your derivative rules, and the more practice, the better, as long as we're practicing correctly. Now, I gave you a handout today. Go ahead and get that out. I gave you a handout today. We're just going to look at one of them, and probably after the test, we'll look at the other one at some point. This is your first exposure. This is your first exposure to an AP exam from an actual year free response question. AP Calculus AP free response question from an actual year. We could have done parts of FRQs up to this point, but we couldn't really have done a full FRQ up to this point, so you haven't seen a full FRQ yet. You've been seeing little bits and pieces. However, For the rest of class, I want to stress to, because this is what you guys haven't had tons of opportunity to do yet in this section. I want us to read, this is number 1, right? I want us to work together to read a problem, understand what it's saying, and try to translate mathematically what we can show or what we can write in order to signify what's going on, and then see if we can work through some of these problems. But a quick heads up for my underclassmen that are going to be gone tomorrow. We have a few multiple choice from the end of the section that we'll work on in the back of our spiral first thing tomorrow. We're not grading 2-7 tomorrow. We'll wait until you're back with us on Thursday. We're going to grade things all together on Thursday, but we literally have like 20 minutes. Actually, let's do this, guys. Instead of grading things all together on Thursday, let me go ahead and tape grading in period 6 tomorrow. Does that sound good? I'm going to tape grading in period 6 tomorrow because they have time to get everybody there. And that way you guys can grade on your own time so that we can use the 20 minutes on Thursday just for like quick review questions. Sound good? So then Thursday we'll have our quick review, Friday our test. Sorry that the week is what it is, but that's something that none of us can control. So let's go ahead and finish this off. Any quick questions about logistics then? We're okay? Multiple choice, you guys kind of remember I said that you have approximately 1.2 minutes in the grand scope of things on a test. FRQs, you have approximately 15 minutes. Approximately 15, but you're going to want to use more on some and less on others. So let's just read through and see if we can translate mathematically what's going on. The wind chill is the temperature in degrees Fahrenheit a human feels based on the air temperature in degrees Fahrenheit and the wind velocity v in miles per hour. If the air temperature is 32 degrees Fahrenheit, then the wind chill is given by, hey, they gave us an equation, that's nice, and is valid for v between 5 and 60. Letter A, find W prime of 20. Find W prime of 20. Using correct units, explain the meaning of W prime of 20 in terms of the wind chill. Find W prime of 20. Alright, cool kids, how do I find W prime? Just take the derivative and plug in 20. So I can say W prime of V is equal to 55.6 is just 0, right, when I divide it. Then I have negative 22.1 times 0.16 V to the 0.16 minus 1, right? That was just all my work. As we get more into application problems, we'll see how amazing our calculator really is and that it could do some of this work. This is a calculator problem. But if I want to go ahead and plug in W prime of 20, I could go ahead and throw it in my calculator. This is a decimal. This is not by hand. I would get negative 22.1 times 0.16 times 20 to the power of 0.16 minus 1. Did you guys get negative 0.286? I hear a lot of yeses. Be careful. We have a number. A question, what would the units be? This is a rate. If it helps you, couldn't I say this is D who? W's the big one, and who's the little one that we're taking the derivative? dV. Does that help me at all with units? Who's W? Degrees Fahrenheit. And who's V? Miles per hour. Awkward, right? But degrees Fahrenheit per miles per hour. Do you see that from the W prime? Not so much, but you do from the differentials, dW, dV. Now, in context of the problem, whose rate of change is this? The wind chill. So we could say the wind chill is this a positive rate or a negative rate? So we could say the wind chill is decreasing at a rate of 0.286 degrees Fahrenheit per miles per hour. Why do we not keep the negative? What word did I use instead? Decreasing at a rate of 0.286 degrees Fahrenheit per miles per hour. You could say something like when the air temp is 32 degrees Fahrenheit. Now I know that we didn't get through a lot of this today. Our main goal was not AP practice, it was commercial related rates. But at least you got to see at least reading, interpreting, units. Okay, guys, work on your 2-7 homework. And if you have questions, 0 periods tomorrow. That's open for everyone. Better not get repeated. And I'll be here after school today and tomorrow. Fierce day after school. Bye, guys.
It's not today, right? That's tomorrow.
Lunch meeting could be hard to sit people, even though you're not particularly hard. It's not your guys' fault. It's technology. Wind velocity. Yes, I will.